Welcome to Interaction and Motion Capture. We're going to look at ways of capturing interaction and capturing motion using processing alongside lots of other little tools. So, for an overview, we're going to look at interaction history, some techniques, some of the main technologies, and some strategies for using those technologies. So, a little bit of history. There's been a lot of work done in trying to understand how people can interact with machines over many years. So this example over here on the left-hand side is the theremin. The theremin has two aerials. You'll see this curly aerial here and this tall one here. And they control the pitch and the volume of a tone. So as you move your hands closer to the aerial, that increases the value for that particular element and changes the tone. If you can imagine, if you move your hand backwards and forwards, you get like a tremolo or a vibrato sound. So, and you can play tunes quite effectively with this device. This device here we may recognize as one of the first computer mice. On the underside it has a couple of wheels, and this is the button. This was a prototype developed to understand how people could interact with computers using pointing devices. Here we have the Wiimote from the Nintendo Wii, which came out a few years back now, about 15 years ago in fact. It was one of the first devices that had an accelerometer built into the controller, so you could do things like play tennis or something like that. Over here we have Michel Weisfich, who created a musical instrument called the hands, and you can see there that they fit around the wrists, and you press contacts here to control the instrument. It's a very expressive instrument, but it doesn't require motion capture in the same way that others do. And this is a touch screen. In fact, I think it's a Lima touch screen, one of the earlier devices used for controlling sounds with a touch screen. This wouldn't be kind of complete without mentioning the mother of all demos, which is available if you click the link on the slides. It's a good idea to go and watch this. It's quite long, but you can skip through some of the more boring parts. But this demo introduced, it was a demo of a computer system, the online system, and it introduced so many of the technologies we now use all the time in one go, and they did it in 1968. So it's quite an amazing piece of footage. It's worth working through to see all of the different parts of that demo. This is probably not as exciting as that, but Minority Report was well known for introducing a lot of the big ideas in gestural interaction. So you can pull up that video and have a quick look through how a gestural interface may look. This was based on real research done at MIT Media Lab, and there's a company called Oblong Industries who market a system that is fairly similar to what they were showing here, but obviously possibly not quite as fictional. And there's a long history of sci-fi reimagining the way that we might interact with computers. And here is 2001: A Space Odyssey. 2001: A Space Odyssey, not Oddity. That's David Bowie. Here you have a precursor of the Apple iPad. Basically, he's eating food and watching TV on his iPad. But this was I think 1962 that this film came out. It was very, very early indeed, and it was well ahead of its time as far as the ideas. It also had a Skype call that was in the start of the movie between the protagonist and his daughter, so it really did understand what was coming up fairly accurately, in fact. On to motion capture. Motion capture systems have been around since the 1970s, but optical systems have been particularly popular in the last 20 years. We have active and passive markers. This is a system that has a camera, the Vicon system, with a number of infrared illuminators here, and the Lycra suits you wear may have a number of reflective balls that are more easily lit up with infrared light than the rest of the suit. So it's easier to see where the joints are and where the wrists are and where the shoulders are and where the back is and where the feet are and things like that by looking at these reflective markers. By putting this all together, you can develop a little skeleton of the person and understand how they move through three-dimensional space. And importantly, you don't just use one camera. Here we have positions for 8 separate cameras. So you manage to capture the markers from 8 different locations, and that means you can avoid things like occlusion. There are some other non-optical systems. We have one called an MVN suit by Xsense, and that uses a number of, you can kind of see it down here. It uses a number of accelerometers and gyroscopes placed at important locations on the body so that you can capture rotation and force being applied in different ways. The advantage of that is you don't need all the cameras and you can walk around in any space and be captured. Motion capture systems made a big jump forward with the Kinect, which we'll use in this course. Basically, the Kinect camera is a structured light camera that is able to see not only the light from the scene, but it's also able to create a depth map from the structured light. So structured light is a set of dots that are projected onto the surfaces of the room that come from 2 different locations. And based on the way that they overlap, you can tell how far away that particular object is from the camera. That means that with that information you can guess what the depth of each surface in the scene is, how far away each surface is, and you can make like a depth map of the scene, as well as having a normal camera to see what the color of the light is. So this structured light works in the infrared plane. So the infrared spectrum of light is not visible to the human eye. It's actually kind of heat, but we can illuminate surfaces with infrared light in quite a lot of detail and have an infrared camera see that particular light without affecting the visual plane at all. So here's an example of a depth map. You can see that the hand is close and it gets a higher value than the background, and the person is a bit further back, their body's a bit further back, but you can see their hand is coming closer. So that's a depth map. With the depth map you can go a bit further and create a skeleton, and here we have a skeleton of the person. Now that requires more processing of the imagery. The program has to guess where all the joints are and put them together. But it is possible just to look at a scene and not require any fancy suits or cameras, and just use the Kinect to get a skeletal tracking system up and running fairly quickly. That means you can say, where's the head, where are the arms, where are the legs, instead of having to look at the whole body as a blob, so to speak.